Hi guys, how's it going? Today we will be learning how to take a product, a chain, and a quotient rule to derive to take derivatives essentially. These are the fundamentals in calculus, and once you get them down, they will become second nature. But without further ado, let's jump into them. So let's go through the product rule first. So let's define a function f of x is equal to h of x times g of x. And so what the product rule allows us to say is that the derivative in terms of x, which I write as f prime of x, is equal to, we take the derivative of any function really, I'll take the derivative of h prime of x, carry down the other one, and then take the derivative of the other one, and carry down the h of x. Now, in this case, it doesn't really matter which function you take a derivative of and which one you do not, and you just carry down, because in this case, it is just positive, so addition is commutative, and so whether you write it that or you write it as just as terms switched around, it will not make a difference. And that is one of the great things about product rule. You eliminate a good amount of calculating error. So to illustrate product rule, let's just jump into an example. We'll take an example of f of x is equal to 3x squared plus 10, and we'll multiply this function by 4x cubed plus 27. Now, when we take the derivative, we'll apply the chain rule, and so we take the derivative of our first function, and so we'll have 6x, thanks to product rule, 2 times 3 is 6x, because it's 2 minus 1. The constant goes away to 0, times the other function, and then we'll add the other way now. So we take the derivative here, 12x, 3 times 4, 12x, x, 3 minus 1 is 2, so 2, and then 27 goes to 0, and we just carry this function down. And that is a derivative, so during the beginning of calc, it might seem a little weird, but eventually this one will become second nature and relatively easy as you move forward. Now, moving on to the quotient rule, it is much less used, and I'll explain why towards the end of this video and later in calculus, but it is relatively useful nonetheless. So let's define a function of x in terms of h of x over g of x. And so when we take the derivative, the quotient rule allows us to write that derivative as g of x times h prime of x minus g prime of x, h of x all over g of x squared. Now in this case, unlike the product rule, the order between these two terms does matter, and so we do have to be careful on which one we take the derivative of first. A nice way you can think about it is, so we start from the bottom, so it's low, take the derivative of the high, minus the high, take the derivative of the low, all over the square of the bottom, and then you're done. But many common errors that we do with this is, as I said before, changing these two terms and taking the derivative of the bottom by accident, or forgetting to square it. And so, an example of when the quotient rule is used, let's say, is when f of x is equal to 3x plus 10, keep the same as last time, and 4x squared plus 25, let's say. And so, the quotient rule allows us to write f prime of x as, put down the bottom, take the derivative of the top, so 3x plus 10, 10 goes to 0, 3x through power rule, x goes away, and we're left with 3. minus, we'll take this one, and then we'll take the derivative of the bottom. So again, power rule, 2 times 4 is 8, so 8x, x1, that's good, and then 25 goes to 0. We put it all over the square of the bottom. And there you go. Now, this one is a little more writing out heavy than the product rule, and it, at least for me, was a lot more prone to mistakes. So I'll, after the chain rule, I will show you another way that you can take this, which can give us a more reliable answer. Now, the chain rule is probably could be one of the more useful ones because you will see it everywhere later on in calc. And when we write out the chain rule, we write it out as f of x is equal to h of g of x. And so what the chain rule allows us to do is represent f of x, f prime of x as equal to the derivative of the outside function times leaving the inside the same times the derivative of the inside. And so it really would not matter how many outer shells, so say you have, you would still take the chain rule the same way. So for example, if we were to say k of g of h of I of x, f prime of x, it really would not be as different as our last example, but we just have more shells down here to count for. So we'd have k prime of keeping the same things inside times, now we take away the k layer and we take the derivative of the inside layer. And now the h layer, keeping the inside constantly the same. Now the I layer. And it's important to note that at the end, when we're done with the I layer, we do not take x prime. That's not a good idea and will lead to some error, as I encountered as well. So this also holds true, but it's a lot nicer to look at. It's a lot less nice to look at than g of h of x. And so to hop into an example of this, we can represent f of x is equal to, let's say, 5x, I'll run through 2 examples of this. First one will be e to the negative 3x. Now, e to the x itself is a very cool function, and we can explain in another video why e to the x is the derivative of e to the x is equal to the e to the x, which is actually really fun to think of, etc. But right now we'll just give you this as a fact. But we can note that from here, through the chain rule, f prime of x is equal to e to the negative 3x, because e to the negative 3x, that derivative is just e to the negative 3x times the derivative of the of the exponent in this case. And so the derivative of negative 3x would be negative 3. Now, even if this 3 was not here, we would still have to take the derivative because the chain rule does apply to that negative in that exponent, which is very important to know. The final example that I'll show for the chain rule is f of x is equal to sine of 3 of x. Now, f prime of x is the derivative of sine, which is the outer layer in this case, and so we get cosine of 3 of x times the derivative of 3x, which is 3. And so we just rewrite this as 3 cosine 3x. When I was going over the quotient rule, I talked about a less error-prone and easier way of taking that derivative instead of having to take the quotient rule. So what I was talking about was, let's start off with a function, sorry, equal to h of x over g of x. Now, to avoid the quotient rule, we could rewrite this as an h of x times g of x to -1. And then it becomes a product rule and a chain rule, which in the long run will be easier than running out a lot of terms for the quotient rule. But then f prime of x in this case would be h prime of x, g of x to -1, plus, now you take that derivative, and since it's a chain, this -1 has to be, this -1 is the outer layer of g of x. And so taking this derivative right here would change this to minus g of x to -2 through power rule up here, times g prime of x times h of x. And so, although it looks a little complicated, let's jump into an example and it'll be easier to see. So let's take a function f of x is equal to 3x squared plus 11 over 4x cubed plus 23. And so, when we write this, f of x is equal to 3x squared plus 11. And then we can multiply this, or we can take this to -1. And so from here we take a product rule and a chain rule. And so f prime of x will be equal to, we take this derivative, 6x plus 11. Oh, sorry, 6x, because the 11 goes to 0. And we just carry down this term. Plus, now we carry down this term. And now we take this derivative with the chain rule. So, negative 4x cubed plus 23, as we leave the inside of that chain rule still this argument. And now we take the derivative of the inside and we end up with 12x. Now, on the contrary, if we had done this through a quotient rule, we would have the following equation. Well, and after distributing various parts and rearranging this through algebra, we can see that this will be equal to this in the long run. But at least for me, when I was just starting out with the quotient rule, I was never able to put these two terms in the right order, and I would keep messing it up either on practice problems or on quizzes. So I literally just changed into taking a product and a chain rule, and it helps a lot through practice. But that is pretty much it for this video. As you start doing it more and more, it will become pretty elementary, and you will start to see certain patterns that you can replicate over time. Yeah, thanks for watching, and I hope you learned and enjoyed.